Morning. I'm gonna start recording. That means I'm gonna turn off the lights. How's everybody doing?
Tired.
Everybody here except Dylan. Oh,
I know.
Dylan.
I hope you didn't break his back.
I hate you.
Oh no, yeah, don't worry.
Listen here, you.
Okay, so yeah, I'm not one of those like I forgot the attendance sheet. That's just who I am.
You
Like,
called my name down?
it is like it's in my DNA. Somewhere there's like one little thing there that says always forgets attendance sheets. Like,
Well, it's only first time you forgot that.
yeah. No, I like, but that's all right because I think we're in a point right now where like my whole point of bringing the attendance sheet every day is to sort of keep this momentum going in the class, and this is not a class that feels like it's losing momentum, so I'm cool with that.
Are you sure about that?
Well, by and large, this is not a class. So we're gonna hop back into this in just a minute here, but before we do, I thought we should look at D2L. So this week is a little weird. We'll hop into week 11 here in just a second, but right now I'm back in week 7 where the breakfast assignment project was. So, hey, what was that, I wonder? Somebody just rang my computer somehow. I don't know. So y'all will remember that this is due next class period.
Sadly, yes.
Can it not be? That is a question.
Yeah, can we keep this to next week?
So here's my thought. I think it's doable, but I think that you all would be stretched pretty thin. So it will mean that we're trimming in just a little bit, not very much, but just a little bit into next week's class and kicking off the final if we hold off. So what I'm kind of proposing we do is sort of an overlap a little bit. All right, so next class period, we will still kick off the final. I'll still announce what the final is, but this project won't be due until a week from today, the following Tuesday. And what that does is that gives you the weekend to be rendering, right? And I think that will help. I'm not actually worried about getting the simulation done. I think we can do that pretty easily this class. It's that after all that's done, you're going to render it and it's going to mess up, and then you're going to have to re-render it. And then, and I don't know that gives you enough time to re-render it, right? If you start rendering at the end of this class, like today, you may get it all rendered by Thursday, but any problems that may pop up in between that time, will be an issue. So unless anyone is opposed to it, how about we push the deadline off until Tuesday? Sound all right?
I'm not complaining.
Okay. Any naysayers on that? All right.
No.
Edit HTML. So that would put it at the 19th. Tuesday.
Thank you.
November 9th.
You gave me a chance to pass.
There we
Not
go.
wrong.
Okay. So, all right. So with that said, let's look at what we're doing this week by just going to week 11. So again, are you all using these videos that are up on D2L?
Yeah.
Are they helpful?
Yeah.
Cool. So these will be pretty helpful this week. We're going to go over simulation just in general. Right? We're going to talk a little bit about different types of simulation. There's a couple of things in here that are going to be helpful because this is not just everybody's projects are going to start to diverge just a little bit in some stuff. So some of you are going to have a different type of simulation, right? Some of you may decide you want to do Cheerios instead of little spheres, right? And if that's the case, there's a couple of extra videos in here you have to watch. The serial rotation, if you're doing something that's like a Cheerio shape or not a spherical shape, it's not going to rotate correctly. So there's an extra step we have to do for rotation. I also tacked on this video here because some people have this issue where, we'll talk about it as we get into it, but what we're going to be doing is we're going to be simulating a bunch of particles, but then we're going to attach a piece of mesh to each of those particles. And in theory, what should be happening is that mesh should render, but the particle should not. But sometimes there's an error or something happens. I don't know what it is. It was like half of the class would get it, half of the class wouldn't, where it would render both of it. So if you're rendering these spheres, you were getting like these little embryo-looking things, like these little like cells with this nucleus thing around it. And that's not like basically this is how to fix that. Right? I also have a couple of other videos in here. One of them is baking the instancer. This is optional. This is sort of an alternative to this caching the simulation. The reason I did this is because caching is not permanent, right? And sometimes you need to make changes that require something to be permanent. Like if you have one piece of cereal that bounces out of your cereal bowl, and you're like, no, I want it to be perfect. I want to delete that one piece of cereal that's messing up. The only real way to do that is to bake the instancer and delete that one piece of cereal. So all of this is like probably gibberish to you, and it makes no sense. But I will get to it once we get to that point. Now, I believe we can get through pretty much everything that's covered in these videos today, but I may be wrong. But I'm going to do my best. But what I will say is because of that, I'm going to kind of go through them at a relatively decent pace. You follow the way that's best for you. If you want to try to follow along, if you want to open up a new version of it, like it's okay to make a stab at it while we're doing it in class. Nope, go to the office, Dylan. I'm joking. Get away.
You live in a society.
Get your tardies there.
Go get a tardies. So actually, last week I went to University High to do like some guest lectures there. Dude, that's a completely different world. High school versus college. Oh man.
Just a wee bit.
There's weird noises that come out of the ceiling, and I'm like, what is that? Is that a fire alarm, or are we supposed to change classes now? Like, what's happening? Anyway, I like this better. That was cool. I like this better. Okay, so we're going to go through simulation stuff today. I'd say what I would do is don't expect to get it right the first time. I guess that would be my plan. So probably the best way to follow along with this is just to kind of save a version of it, open up your scene, and sort of follow along. But if it messes up, that's okay. If you need me to catch you up, I can. But it's going to be a little complicated. It's going to be a little slow. Like really, what I would like is for you to ask questions as you hit problems, so I can answer all of the little questions. Because some of these questions will feel like they'll like completely hang you up, and you can't finish the project because you don't know why it's doing this thing, right? Yes. Yes. Yeah.
Okay.
So yeah, if you've been if you go save scene as and just name it something different, then your old file is now untouched. And so you can call this like playing with simulation or whatever. So I'm going to do a couple of things in a separate my file just so I can show you how it kind of works. But yeah, otherwise let's go ahead and get going. I'll open a new my file and I'll go and pull this over here. So I got a okay. So we're going to play with a couple of different things, but all of this today is related to simulation. Right? So simulation is a word that people throw around for a lot of different things, but in this case, we're going to use it for any motion or movement or events that happen that would be difficult to manually control, right? So it's like a giant, like, just think of simulation as this giant bucket that we're going to throw a whole bunch of different things into, right? So we know how to move stuff around with keyframe animation. How would we keyframe smoke, right? Smoke gets bigger and smaller and changes shape, and like it's never the same shape, right? How would you keyframe water, right? Like water doesn't bend in a very it's like our arm bends in the same place every time, right? Water changes, and so some of these things are like, or I guess another example of this would be like rain, or even like this cereal we're going to pour out of there. You don't want to have to animate literally hundreds, if not thousands, of individual pieces of cereal falling. Like that's just it's not impossible. It's just extremely, extremely, extremely inefficient, right? And so we use the computer for what the computer is good at, which is a whole bunch of small calculations. And instead of us manually trying to create those motions, we let different systems within Maya simulate those motions, right? So I wanted to talk just a little bit. I think we've briefly opened some of this up and looked at it before, but I wanted to talk about a couple of those, right? Let's start off with particles, okay? Because particles are something we're going to be coming back to here. So everything to do with simulation is going to be listed under Effects, the Effects menu, FX menu. And if we go there, you'll see that our entire menu changes, and a lot of these things have the letter N in front of it. So we have N particles, N cloth, N hair, N constraint, N cache, right? All of these different things. So that N is a system that is in Maya for simulating physics. The N stands for nucleus. So it was the nucleus physics system. It's not super new in Maya, but it's one of the sort of the staples in there of simulating stuff. And so with it, you can simulate some fabric stuff. You can simulate hair. You can simulate like particles and fluids. Fluids as it's called fluids, but it's actually more like anything that is fluid, like smoke or steam. Or fire. And then on top of that, we have all these other words out here that are probably they just sound like the names of stuff, right? Like mash and boss. You don't see it up there, but there's another one we can turn on called bullet. All of those are different simulation software plug-in packages that are attached to Maya that allow us to simulate different things. There's also another one, I don't know if it's listed up there right now, called Bifrost. And Bifrost is what is mainly right now used for simulating flowing liquid or flowing water, right? But soon will actually become sort of the simulation system that is going to replace a lot of the older nucleus stuff, I think. So all this stuff, the algorithms, the technology that is used to do this simulation, it changes, and a lot of times there's different things that you would plug into this. So we're going to mainly be looking today at nucleus, but recognize that this takes some familiarity with it to understand which is the best tool to use for it, right? And we could spend class periods on talking about the different systems in there. So much so that there is a class that's the entire purpose of it, is just to try a little bit of all of it. Interestingly, although we're going to do some simulation in here today inside of Maya, the simulation software, the effects software that is sort of on the rise and that most people are using right now is actually called Houdini. Anybody heard of Houdini? Yeah. So in the effects class, you'll be using a lot of that. That's one of the reasons Bifrost is kind of changing, I think, is to kind of compete with Houdini, and it does some similar stuff with what's going on in Houdini. So if effects is something you're really enjoying, just recognize that there's a lot to it, and there's not just a simulate button, right? It depends on what you're trying to simulate and how you want to do that, and which system you're going to use. So we're mainly just going to focus on the nucleus system today. And again, that's anything that has this N in front of it. So let's just start with the first one, N particles. Now if I expand this out, I want you to watch out for something. Because some of these things I'm going to tell you to do up here, like create emitter, that's listed twice on here. And one of them is under emit, and one of them is under legacy particles. So before the nucleus system existed, there was another particle system that existed. And people still need to use that sometimes, or still have old shots that have those in them and want to be able to open them. So that still exists within Maya. But be careful when you're creating stuff that you're not using anything from the legacy section down here at the bottom. Right? We're going to be using this stuff that's up at the top. So I'll just say create emitter, and I'll sort of show you what we get in our outliner when I do that. I get 3 new objects in our scene. We get emitter 1, we get M particle 1, and then we get nucleus. So those 3 things didn't exist before I hit create emitter. So, so what does that, let's talk about just briefly what those 3 things are. Nucleus, the nucleus 1 node there, is the thing that tells Maya physics exists, right? Maya doesn't have to know that for every shot. It's the thing that creates gravity, it's the thing that creates friction, it's the thing that lets that even be a thing that Maya needs to be calculating in this scene. The emitter node right here, so you'll see that the nucleus node is sort of this N shape with this funnel at the bottom here. And that can be anywhere in your scene, but you'll see over in our attribute editor, it's got things like our gravity in it, air density, wind speed. Like this is just sort of the world of physics exists now inside of Maya because of this nucleus node. The emitter is what is going to spit out particles. Okay, so again, we're emitting particles. The emitter is going to spit them out at some rate and in some way. Right? The emitter is the actual thing, the actual place that they will be coming from. Right? And then the N particle 1 node, right there, you don't really see it, and that's because those particles don't exist yet. This is a node that is sort of a, it is the way that you pick all of the particles after they've been emitted from the emitter. Does that make sense? So the emitter is going to start spitting out a whole bunch of little dots. After they are out of the emitter, they're their own thing, and they're all sort of encapsulated into this N particle 1 node, right? So to show you what this looks like, I'm going to hit play. And it's going to start spitting out a whole bunch of little dots, right? Now, it's spitting them out really fast, and we're playing back really fast. So I'm going to stop here for a second. And every time this has happened in the past, you've told me, or you've heard me say, right-click and go to playback speed and set to real time, right? Well, this time, I'm not going to say that. Oh, mixing it up on you. Because those other 2 have to exist for some reason, right? So when we set it to real time when we're animating, when we're setting keyframes, because we want to be able to see what our final animation is going to look like, right? We want to see it play back at the speed that we wanted to see it. And if for some reason our computer is running a little slow and it starts playing a little jittery, at least we're seeing it at the right time, right? At least we're seeing it move at the right speed. However, so it really doesn't affect us too much if it has to skip 1 frame or 2 every now and then, right? Yes?
Oh, I'm sorry, I'm not raising my hand. Sorry.
Oh, okay, that's fine. Oh, okay, gotcha. Oh, no, you're fine. I didn't know if that was like a question, but I don't want to ask it. No, you're fine. So that's why we would set it to real time, so we can see it. But in this case, to simulate something, Maya to know where all of these particles are on frame 55, Maya needs to know where they were on frame 54. Right? It's like it's looking at it 1 frame after each other in order to see how this is going to simulate from frame to frame. So if it skips frames because it's playing back too fast, or trying to play it at the right speed, then Maya loses track of where all those particles are supposed to be. Right? To sort of show, so what we usually want to set this to is one of these play every frame options. Now, if we set it to play every frame free, it's going to play it as fast as the computer can, right? But what we're going to set it to instead is play every frame max real time. And that means it won't play it faster than 24 frames per second, but it'll still not skip any frames when it's playing it, right? And so then you see what we're getting is this, right? Okay, I'm going to extend my timeline out here pretty far. Let's extend it out to like 2000, right? Now the cool thing about this, if we watch it, as I zoom out here, you'll see that it's going to keep emitting these particles for a long time. Now, if I stopped and tried to scrub my timeline, you'll see it doesn't work. When I'm dragging it backwards, nothing's happening. And when I'm dragging it forwards, they only go forward, right? So this is a simulation. Again, it needs to know what's happening the frame before it can tell you what's happening the frame after. And since I've been doing this, when I release the mouse, I'm going to get a little bit of an error down here, right? Nucleus evaluation skipped, frame changes too large, right? So I basically just messed up that simulation by trying to scrub it. So the only way we can really see a simulation the way it's supposed to be is to hit this back button right here. All the way down the bottom corner, goes all the way back to the beginning, and then hit play again and start to see it emit. Now, question you may all be actually you probably have a few questions sort of floating in your head. I'll try to sort of check those off as we go. Do those particles just keep going forever? Yes, they do, unless we tell them not to, right? So that means that this thing is emitting particles and emitting particles and emitting particles, and if I let this play forever, eventually there'll be so many particles in this scene that my computer will catch on fire, right? I guess like it really won't, but it will, like, it can cause it to crash because we're asking it to simulate a whole bunch of stuff, right? Is it causing your
Yeah, I can't. What? I opened another one, so it's fine. I'm following it.
Anyway. So
Derek's waiting on the fire.
So at this point, I'm at like 1,400 frames, and the question you may have is like how many particles are in there right now, right? Well, there's a way we can change the number of particles and the rate at which they're emitting, and that's all going to be something that we would see under the emitter. Now, let me sort of show you this. If I select the M particle 1, what I'm selecting is that thing that's been emitting all of this time, right? All of these particles, this big box of particles. So there's certain things about that we can change, including the lifespan of these, right? Now, before I go do that, let's look at the emitter. So the emitter can allow me to change what the shape of the emitter is. Right now it's an omni emitter. So even though you can't really tell it, it's actually a ball that is spitting out particles in all directions, right? It's like an explosion happening outward. But the reason they're falling is because gravity exists, right? So it spits them out, and it's just kind of like a fountain. It's just kind of like pouring out of it and falling down, right? So we can change things in here, but what you'll see is happening is right now 100 particles a second are emitting, right? And we are at 1,424 frames, right? So, so we could do some math and figure out how many particles that means are in the scene right now. I'm not going to do math because I don't like math. Yeah. So I'm going to go back to the beginning here and change this, though. And instead of 100 particles a second, I'm going to say something more like 1,000. Right. And you'll see that what it emits is a little bit of a larger amount of particles. And I can, of course, that's a number that can be animated over time, where we get fewer or more particles over time, right? We can get little surges of them. Yeah. Yeah. So the other thing you'll probably see is the speed at which they're emitting is set at 1, right? Which means they're sort of spitting out there at like an okay speed. But if I crank this up, you'll start to see it starts to spit them out a little bit more, right? So this is a way that we can kind of cause little like splashes to happen, right? Okay. So I don't remember what I set my. Let's go ahead and set that to. Let's do 500. So we have 500 a second. So that means every 24 frames, there's 100 of these. Every 48 frames, there's 1,000 of these, right? And so that number is going to start adding up really quickly, and that will start to bog the computer down. So let's go back to our n particle 1 shape and look at this. So right now, the lifespan of these are to live forever, right? Which means they will live forever, just like we all want to, right? I'm going to change that. I'm going to change it to constant. And so now the lifespan of this is 1. 1 what? One yes.
1 second.
Yeah. 1 year.
So yeah, 1 second. And so you can see that once those particles have been alive for 1 second, they just kind of disappear, right? So think about this. What all could these particles be used for, right? Like they could be, we could turn this into something pouring out, like sugar or something like that, right? We could also maybe use these for like fireworks or something. And fireworks don't just keep expanding forever. Eventually they kind of burn out, right? There are other things we could use these for though, because these little points can render differently. So I'll show you that here in a second, but that's something to think about. Like if we wanted to use this for like some form of flowing water, we could. And the way we would do that, so that's just something, we'll come back to how we could do that in a minute. So let's change this from constant to random range. So random range, I changed that and it doesn't look like anything changed, but that's because we're playing. If I hit stop, you'll see that those other values opened up there. And so now my lifespan is at 1, but I want some randomness in there. So let's say more like my lifespan is at 2, but I have a randomness of 3. And so what that means is now some of them are going to die at 1, and some of them are going to die at like 5. Right? So let's change that again. Lifespan of 1, random of like, yeah, there we go. So we'll start to see if they die off a little bit of a different time, right? Okay. So there's a couple of other things that we can play around with in here. One of them is particle size. Right now the particle size is 0.2, and if I crank that up, it doesn't seem like anything really changed. Right? Like turn that up way up to 20 instead of 0.2, and they still look exactly the same. Right? So let's go look at why that is. Because right now these particles are rendering as just a dot. Right? There's no mass to them at all. We can zoom in forever. They'll always be just a dot. Right? So this is really just a tick mark for us to know that that particle is there. I want to go ahead and create a sky dome in here though. Let's see, lights, sky dome light, and render this really quick and see what they render like. So they're kind of rendering as just dots too, but if I get in there close enough, you'll see that they have a little bit of mass, right? So Arnold doesn't know what to do with a particle, so it replaces that particle with a dot as a little bitty sphere, right? And so that's something that we're going to kind of run into some issues with later in the way that Arnold renders this. Let's go ahead and hide that again. So what we're going to do though is, if I go to this M particle 1, I can scroll down here to, find it here, is it shading? Yeah. Under shading, we get this particle render type. And right now it's rendering as points. Right? And I can change that to be different things. So if I change this to multi-point, each point is going to render as a whole bunch of different points, right? So that's a way that I can get way more looking particles when what's actually being calculated is that, right? It's like each point is rendering as a little cluster of points. I could also do multi-streaks, and it starts to look a little bit more like sparks or something, right? Trying some of these others here. I can do spheres. I start getting something like that. Or I could do, let's try some blobby surfaces. It's very similar. Right here, clouds. This is the one that's kind of interesting. So the problem with clouds, like this would be really cool if it worked, right? I feel like that's something I say a little bit too much with Maya. The problem with that is when I render this, it renders it as that, right? Arnold doesn't know how to render that cloud thing. And that's why when we selected clouds, you would see that out here there's a little SW. That means it only works in the software renderer. Right? So this only works in Maya software to get the clouds. So that becomes a little bit of an issue. There's rendering workarounds for this. But that is one of the things to kind of be thinking about. So I wanted to show you this though. A lot of people like this. It's not perfect, but it's kind of neat. I'm going to change this to spheres. Right? So that's kind of, if I render that now, what does that look like? So it's going to render it as these actual like sort of balls, right? Like, and they're kind of glossy. What I'm really wanting though is if I wanted this to look like liquid, I could start using this as sort of a starting point, right? And one of the ways you could do this is after you get your simulation working as these spheres, we can go to modify and then convert, and we can convert let me find it, in particles to polygons. And so now what I get sort of like this, which doesn't exactly look like liquid. But if you can get these to cluster together a little bit more, then you can sort of start turning this into a little bit of a globby type of surface. The problem with it is you can't really go back after you convert it, right? So, I mean, you can undo to before that, but you can't really make a lot of changes to it. So, so I want to show you one more thing too, though. Once we get in here closer to these surfaces, you'll notice that they're all kind of colliding together. They're all kind of bashing through each other, right? In fact, I can make a plane here. Let's go ahead and do that. I'm going to scale this plane up really big and move it down to here. And because of this nucleus system, I can make things collide that are nucleus objects. I can make them collide with this plane. Right, let's go ahead and add a material to that just so we can see it a little bit better up there. Just going to add something so you can. Right. So right now it's going to go through it, right? And the reason for that is because Maya doesn't know that this is something nucleus should be affecting, right? It's not going to affect everything because that's just a lot of calculations that would be unnecessary, right? So we have to tell Maya first this is something that it should collide with. Now, for some reason, I think it's just the order in which they implemented all these tools. Some of these tools live in menu paths here. So I'm going to go to the in cloth option, and I'm going to, with the plane selected, I'm going to choose create passive collider. So now what happens is they're going to hit that and kind of collide with it, and they'll start to disappear, right, after a time. So, but it's still like they're not really globbing up and they're not really hitting each other. So they're colliding with this, but they're not colliding with each other. So that's under this in particle 1. We can see up here toward the top we get collisions. And right now self-collide is not checked on. So if I hit it, now we're going to get something like this.
Oh, what's
Yes.
The self-collide option right here.
Oh.
So I could actually go up here and change that lifespan to live forever. I'm just going to start.
That's a lot. Oh, already coming.
Now you'll see as we get a little bit in here, Maya starts to play a little slower, right?
Get in there.
Yeah.
That's a lot of
Keep going.
And eventually it'll crash. So now though, if I went back and changed this to modify, convert M polygon or M particles to polygons, and I have to go back to my first frame to simulate this. It doesn't look like it's working. What's happening? Huh. all right.
Oh my goodness.
Rewind about 15 seconds and pretend I didn't say that. So, what?
Stop cringing. You're just like disappointed.
Yeah. Okay. So here's something. Sort of the last thing I'll really talk about with this before we move on is sometimes I don't want these simulating as these spheres, right? I'm going to go ahead and change that back under nucleus. I'm going to go ahead and change that back to those points again. And you'll see they still simulate as if they are about that size, right? Like they still have this shape around them. And that's still under this collide. If you want to see the size of the thing that is colliding, it's this collision thickness right there. So that's what's colliding with each other, but how it's rendering is as these little dots, right? So really what Maya is doing is it's just calculating the location of these things, right? So let's say that what I actually wanted to be simulating wasn't these little dots, but it was a bunch of these, right? Just a whole bunch of little pyramid things, right? I'm gonna make it a little smaller. Let's make it a color you can see too. So assign new material. Something that will harshly stand out against that red. There we go. So I have this cone, right? And I have this M particle 1. So I'm going to select them in that order. Cone, and then M particle 1. And then under N particles, I'm going to choose instancer. So an instance means that there's a duplicate of an object, right? But it is going to still respect the original object. So if I change the original object, all of those duplicates will change too, right? And it's a special type of object that you would need to use in a lot of different situations. But instancer now will replace all of those polygons with these little Christmas trees. And so now we're raining down Christmas trees all over the world, right?
Is this how God made the earth?
Uh-huh.
Wait, I still have my balls in the seat though.
So you can still see it here, right?
Yeah.
So one of the ways you can do that is just put it under the floor.
Deep trees.
Look at all the happy little trees.
Now, here's the cool thing about that is since this is an instancer, I can change this original object. I go to this vertex and change it and make them all a little flatter if I need to, or all a little taller, right?
Oh God. This is where you make spikes from.
Mm-hmm.
Make them upside down. And put a person under that would be funny.
So, I want you to be thinking about this. What shape is your cereal? Right. Now, it's very easy to come up with some really cool shapes. Recognize that none of those trees are rotating or flopping around though. The simulation really is just calculating their location. Right?
The computer's gonna die eventually.
So that means if we wanted to calculate anything else, we have to add that to it in a special way. I'll go ahead and tell you the easiest way to do this project is to do spheres of some sort. So little chocolate, like what is it? Cocoa Puffs, right? Like Cocoa Puffs or Tricks, or like one of the or is Tricks around? Okay, yeah, Tricks are around. So something like that. And I know you may have already made a Wheaties box, but I it's your call if the cereal that comes out of your box doesn't match. I'm not that upset about that personally. That won't affect your grade. It may ask some of the other faculty may be like, why are they all around? When it comes to midpoint review or something. It's the special edition. I always say that Mom was buying the Malta Meal brand and putting them in the original box again. So that's what's happening. So now you can use whatever you want to on that. Like, don't feel like you have to make it the shape of the other. But if you or of what's on the box. But if you do, there is a way we can make them rotate. It's just a couple of extra steps, and we'll talk about that as we get a little further. Okay. So this can be a lot of fun. I'm actually going to go ahead and get rid of all this, though. New scene. Don't save. And we're going to talk about a couple of other types of simulation we can do. So I'm going to create a plane. Go ahead and give it a color. Assign a new material. Shader. Actually, I'm going to go ahead and give this like a checkerboard pattern so I can so we can see it a little bit better. Just so we can see stuff happening on top of it a little better. Okay. And I'm going to create another plane. Go ahead and scale this one up a little bit. And move it up a little bit. Now, what I'm wanting to simulate is this as a piece of fabric, right? Like a piece of cloth falling. Like any object that you're going to deform, the more detail you have in the mesh, the more detail you would be able to get in that deformation, right? You want to be careful not to crank it up so high that everything gets like running too slow. But if I want a piece of cloth to simulate, like that's not a lot of segments for it to bend. So I'm going to go ahead and add some more segments to this piece of cloth. We're going to channel, box. And instead of 10 and 10, maybe I'll do 50. Right? So it's got some more detail in there. Now, we actually already probably saw in one of the menus how to create this piece of cloth now. If I select it, I go to In Cloth, you'll see that there are two things under Create at the very top. There's Create Passive Collider, and there's Create In Cloth. In Cloth is something that is going to simulate and deform because it collides with things, right? It's going to change shapes. A passive collider is just a hitbox. Like it's just a thing for it to collide with so it can change shapes. So the passive colliders are not going to change, the in-cloth will. Right? So if I create in-cloth with that selected, you'll see that I get both the nucleus node that we need for anything nucleus to simulate and the in-cloth. Right? Now I still have the original plane here, but the plane is going to be deformed by this in-cloth node. And so if I hit play on this, it's going to fall. Wow. Impressive, right?
So glad I'm taking this class.
Technology. Assign new material. I'm going to go ahead and give it some, yeah. Have y'all seen the commercial for the hurricane? Y'all seen that?
Oh, yeah.
Yeah, I love that commercial. It's this cane that like folds up and like has like feet to it, and so like when you take it out of like your bag or whatever, it just sort of expands out and you have a cane, right? It's ready to go. So you're you got a hurricane ready to go, right?
Stop it.
And somewhere in the infomercial, this little old lady says, "I don't know if this is what you call technology, but it's wonderful." So me and my wife are like, "No, that is not what you call technology. That's a stick. That was the earliest invention." But anyway, this technology gets a little better than that. Right now, so we have this thing, it simulates, but there's nothing for it to interact with, right? As it's interacting right now, it's falling through evenly dispersed air and hitting nothing, right? It's also falling perfectly straight. So if I select the floor, I can make it at least collide with the floor by going to nCoff and saying create passive collider, right? And so now when it falls, it'll hit the floor. So it's getting a little better, I guess.
Being more intelligent, oh my god.
Yep.
It's growing further.
So, but again, everything is perfect on this, right? Like it would be impossible for us to actually drop something that perfect, like to stretch a piece of fabric that perfect and drop it. So let's just mess it up a little bit. If I rotate it a little bit and drop it like this instead, then we're starting to get some simulation on that, right? Let's make it even more interesting. Let's add another passive collider here. Let's add a box. So move this up, scale this up, nCoff, create passive collider.
Wait, what happens if you can't move your plane anymore?
Go back to frame 1 and see if you can move it.
Oh, big brain.
So now it's working better, right? There we go. So the cool thing about if we go back to frame 1, we should be able to reposition all of this. I do something like this, right, and get a different simulation out of it every time, right? Now some of you may be seeing this and realizing, possibly a little too late, but maybe not, that you could add a tablecloth to your table if you would like. Right? Like pretty easily, right? Like look how easy that is. But the problem with it is you don't want it to you don't want your animation to start with this tablecloth floating above the table and then falling and wrapping around it.
Why not?
So there's a lot of uses. There's a lot of uses for this that are outside of simulation, right? We could use this as a modeling tool, right? If I need this to just be a tablecloth, all I really have to do is stop it on the frame that I like it. So maybe there, right? And now that I have that stopped, I can select that original polygon plane, right? Yeah, P-plane 1, and just duplicate it. Control D. So now we permanently have this that I can move anywhere I want to, right? And it will stay like that forever. So now that's just a model that happens to be in that configuration, right? So we could use that to our advantage here in a few minutes. We may play around with that a little bit. So what I'm going to do is I want this to I want to be able to change some of the settings on this, right? So right now this is just the plane I have selected, but if I go to the nCoff, you'll see that it has a lot of options in here as well. Collision, right? Like we saw earlier, I can change the way it collides. I can change the thickness of it. I can change the bounciness, the friction, the stickiness, right? Like if y'all noticed that happened earlier when I dropped it like this, right? It hits the ground and kind of slides away, like watch it like, and it just slides forever, right? But if I crank out the stickiness a little bit, then it doesn't slide as much, right? So the hard part with all of this is there's tons and tons of settings under here. There's these dynamic properties that'll change our stretch resistance, like how resistant is it to stretching, right? Versus compression resistance. If I push it, does it sort of crinkle on itself, or does it try to stay kind of rigid? Each of these are different things. Bend resistance. I can crank that way up and watch what happens to it. Sorry. It goes a lot slower. Let's turn that down a little bit. Try it again. Sorry. So bend resistance turned way up means that when it hits the ground, it's not going to crinkle as much, right? So there's just a lot of settings in here that I can change to make it rigid. I can actually make this turn into pretty much a piece of steel if I wanted to, and simulate like a piece of steel. Meaning that if I dropped it hard enough, it'll wrinkle a little bit like steel would, right? So part of the being effects artist is learning how to dial all of these in to get exactly what you want, right? But there's a lot of presets already built into this that allow you to get some of that without having to fight with it forever, right? At least like a better starting point, right? And what these presets are going to do, if I go to presets, right, this is presets. These are going to give it, these are going to change all of those parameters we're looking at to give you something that is close to what it's named, right? It doesn't mean you have to stick with that. You can change it, you can make it a little bit better, but this is sort of a starting point for all those parameters. So if I wanted to change this to be more like burlap, I could replace that with burlap, and now when it falls, it's going to simulate on that just a little differently, right? It's a little stiffer. If I wanted it to be instead silk, I can replace it with silk. So silk is very light, easily affected by air. I'm just going to miss my box here. And it's going to be very, it's playing kind of slow because it's calculated. So, maybe we want to try something different, like plastic shell. What's that look like? I don't know what's happening. So it kind of like dented it for some reason, and then I kind of went back to normal. So never mind, we're not going to use plastic shell. So there's a lot of different ones. Honey is always a fun one to see. It messes up pretty good. Or we could also do lava. Yeah, lava's kind of. So why this is kind of neat is because I'm doing this on a plane, right? But I could delete that and do it on something else. Right? I could do it on this sphere and raise that sphere up. Maybe add some more particles to it, or more subdivisions to it. Let's do like 40. And then I'll go encloth, create encloth. So now when I hit play, see, like kind of like that, right? So some of these settings are about how inflated this is. So we have some. I have to find it in here. Anyway, I'm not going to dig around through here. There's some, pressure. There we go. So we can add a little bit of pressure to this. And so now it becomes a little bit more of a ball that is kind of inflated. And if I increase my pressure on it, it's a little bit more of a jelly kind of ball. Right? So there's lots of neat things that we can do with this, right? And this is just like literally, we're just a very small chip of the iceberg of what we can do with effects. So what I'd like to do is use some of this stuff we just talked about to create two effects in my scene. The first one I'm going to do is just go in there and I'm going to make me a napkin somewhere for my scene just to add some extra objects in my scene. The other one is going to be, we're going to simulate some cereal. So let's go ahead and close this down and go back to my original scene. So the napkin's going to be pretty easy. I just need to make a plane and then drop it somewhere to get some crinkles in it, right? So go ahead and create a plane, scale that up a little bit. Oh, that's a pretty big napkin. Oh, and I'm in my render cam, so I got to undo that a little. If you ever do a camera move that you didn't mean to, you can use the brackets, like the open and close brackets, to undo a camera move. And that means I need to lock my camera so I can't accidentally do that. And go back to my layouts, 2 panes side by side. So I can use this one as my perspective. Yeah.
How do you delete the emitter?
You should be able to just select the emitter, end particle, and nucleus node from in your outliner and delete them. Yep. So I'm going to go ahead and make a napkin, maybe something like that. That seems kind of big, maybe like that. Add some more divisions to it. And so the cool thing about this is I can kind of experiment around for a little while if I want to. Right? I can take this napkin and I can start simulating a few different ones. Right? So I'll first go to the effects menu, NCOF. I'm going to create the NCOF out of this. Then I'll select my table. Currently I have that locked, but I'll select my table and go to NCOF, create passive collider. And so now if I hit play, I can just start getting these simulations of it. Let's change my playback speed, every frame max real time. There we go. Not really digging that. So change its angle here a little bit. Okay. So I need some stickiness to this, I think. Attribute editor, stop. So my NCOF in shape here, I will add some dynamic properties, or is it under collision? Yeah. Add a little bit of stickiness and a little bit of friction here, just so when it hits the ground, it kind of, yeah, perfect.
Wait, so, okay.
So turn that back down a little bit. There we go. It's going to start pushing itself out. There we go. Maybe something like that. It's not bad. And so once I get that, Control D, call this napkin 1. And then I can always just move that off to the side and keep simulating, right? I can select this one, my bottle, or my glass is right there where I can't see it. Select it like that. And then hit stop, Control D, napkin 2. And so really I'm just creating a couple of napkins to lay around my scene, right? So maybe something like that. The cool thing about this is once I'm done, once I'm done simulating that, I can hit 3 and it'll smooth it a little bit. And so now I got a pretty nice looking piece of cloth there. In all honesty, this is crinkling maybe a little more than I want it to, though. So maybe I would go in here and change my preset on this to something a little more like, let's do silk, but I'm not going to completely replace it. I'm just going to blend it by 50%, just to make it a little like, so I get something like that. And that's not too far off of what I'm wanting. There we go. So now if I hit 3 on that, I get, that's a pretty wrinkly looking napkin. We'll keep going here. Let's try if we added just like 10% burlap. I'll let it unfold just a little bit more. It's freaking out. There we go. What's that?
So what if you get like a warning that says it won't do it?
What's
It's like, or it could just be doing it.
what's the warning saying?
It's like saying the unsupported enable attribute value of the nucleus node has triggered safe mode and caching is disabled.
Them's fancy words.
I know.
That sounds to me like I don't know. Have you tried deleting? Do you have two Mayas still open? Did that other one ever finish crashing?
Yeah, finished. So
Okay.
I reopened it.
That sounds like it. I don't know. I would consider just deleting all the nucleus stuff out of there and trying again on that one. Yes.
How do you link plane and nucleus, but I don't know how to like make the nucleus effect.
So sometimes that happens, like where you create one and or it's something you already had created and you didn't want it, and it's not respecting that. You still have to make it an encoff. You have to hit create encoff. It should automatically connect it with the nucleus node that exists. But if it doesn't, let's see, we have to do constraint. Is it add members? Or is it under in particles? Yeah, I think it's that add members thing under in constraint. But usually, like if you delete the nucleus and everything else when you create the encoff, it'll automatically create a nucleus associated with it. Does that make sense?
Yeah. Do you need to create the plane first, or do you need to create the plane?
If you create the plane and then go to select it and go create encoff, it will turn the plane into an encoff. Yeah. So I can simulate around with this stuff all day. Maybe one of the things I'll try just to get a little bit of a better result is a temporary object in here to collide with. Like that. Off. Create passive collider. So now it'll hit that. Well, that's not what I really wanted. Maybe I'll turn some of that stickiness down again. There we go. Let's try that. Gonna fall off there. Nah. It's like it's somewhere in between. I'm fighting with it here. All right. I'm not going to fight with this forever. Oh, wait, what's that? Control D. So now I got a couple of other options to choose from. And I can go ahead and delete some of that other stuff. So I'm going to delete all of these things that I don't necessarily need anymore. And when I delete that, now I'm just left with a plane. Delete it too. And these 3 napkins I can play around with. So probably what I'll do is I will... that one's a little too messy. You could always do a little bit of sculpting on it if you wanted to. Just hold this and you can sculpt on it. So, but whatever, I'm fighting with this napkin too much. So we'll use this one right now. These other 2, I'll just go ahead and put those under the table where I don't need to see them. And I'll just kind of place this sort of over here in the distance, just so we have some background filler. Right, maybe like that. Okay. So that was just to give us a new object in there that's hanging out. Okay. The last thing we're going to do, the next thing we're going to do, is we're going to go ahead and start simulating some serial pouring out of here. So this is pretty much like a new scene now, right? Or at least doesn't have any of that effect stuff in it. I deleted all that out. And I have to turn that back on mine again really quick so I can see it updating in both windows. So we go preferences. I think it's under time slider. And I want it to update in all views. Let's save. And that way, just when I'm scrubbing here, I can see it playing back in both views. I'll go ahead and freeze my models again for right now. No, I won't. I need those on. So, yeah, I'll go ahead and leave these unfrozen. Okay, so my cereal box is where we're going to start with this simulation. Right? What I need to do is I need to fill up my cereal box with cereal first. Right? And then I need to animate picking up the cereal box, pouring it out, and setting it back down. So let's start with creating an emitter. So in particles, create emitter. And so the place that these particles are going to emit from is from that emitter, right? So it's spitting them out and they're under the table now. So let's go ahead and pick my emitter up. Move it over to here. Over the box. And then I should be able to hit play. Look at that. It's working beautifully. So it's just spitting cereal everywhere. Now the other thing I need is I'm going to go ahead and do mine as a sphere for right now. I'll show you how to do this differently later. But polygons, create a sphere here. And this is going to be my Captain Crunch cereal ball. So I want to get it to about the size I want one piece of cereal to be. So that's too big. Some people go way too small. Like, I think it would be about like that. Maybe a touch bigger. Something like that and that. There we go. And then I'm going to go ahead and apply material to this. Assign new material. Shader, AI standard surface. Now, something to think about on this is your cereal is probably not shiny. If your cereal is shiny, you shouldn't eat it. Just
I don't know.
Just
I
a
had
rule.
This one cereal that looked like metal, but I ate it.
Metal cereal.
It's shiny and milk.
It is shiny, maybe. I don't know. But if your cereal out of the cereal box has already had milk on it, don't eat it. So right now, something to consider is when I render this, will it render as glossy or not? Right? And I think it will. I'm not going to worry about rendering right now. But the reason I think it will is because my specular weight is all the way up. So I'm going to turn that down. And I just mention that because we get a lot of glossy cereal in this project. So I'm going to go ahead and name that one Original Cereal OC. And okay. And then I'm going to replace all of these little dots that are flying everywhere with this original cereal piece. So again, to do that, I choose Original Cereal. I choose the nParticle1 node. Right? And then I go to nParticles instancer. So it's that order. The original cereal, the nParticle1, nParticle instancer. And so what I should get now is little cereals flying everywhere. Yay! Also, to me, those are feeling a little big. Yeah, so I'm going to go ahead and scale down my original cereal just a little bit. There we go. Make them something like that. That feels a little bit better compared to the box. Yeah. So they're going everywhere, right? It's an absolute disaster. Yeah, no joke. So a couple of things that are happening here is the emitter speed is, I think, probably maybe a little high for this size. I could probably do something like 0.1, right? And let's see what that looks like. There we go. That's a little better. The other thing is, I think in this version, I haven't set my playback speed. I did. Every frame, max roll time. Okay, that's all right. So it's spitting them out pretty quick, right? And they're falling through the bottom of the box. Something else I could do to change that is if I wanted to, I could lower my emitter down into the box. So we can kind of play with these different options here. But one of the things we want to do is be able to fill this box up. The only way we can really see that happen is if we make this a collider. So I go to nCloth, create a passive collider out of the box. And so now as this starts to fill up, let me go back here. Where's my cereal going? Look at that. They're flying up into outer space for some reason.
Yo, that's cool.
Yeah. Right. So I will say that there is both there's a reason some of this is happening, and it's actually my fault because I gave you the original scene that was scaled the way it was. So I'll talk about this, but don't worry about the details of this too much. So this scene is actually really small. And the reason for that is because if we look at our grid, let me see if I can turn on the grid really quick. If we look at our grid is really big. Right. In Maya, Maya thinks of each of those little squares on the grid as a centimeter. So this is like tiny ant furniture, right? I did that on purpose. And that's because everything in Maya thinks of those little squares as a centimeter, except for Nucleus. And for some reason that they won't change, Nucleus thinks of each of those little squares as a meter. So your table is roughly to scale to Nucleus. But to the rest of Maya, Maya thinks it's little bitty, right? So that's one of the reasons this is happening. That means when we have everything set to 1 in terms of scale, Maya's thinking of 1 unit. Right? And so what's happening is when I made this a collider, if I go choose my box, I can see my solver display here set to off. But if I turn on collision thickness, you can see that that's the collision thickness of my box. And if I choose my M particle, and I turn on collision thickness for that, or self-collide thickness, or sorry, solver display for collision thickness there, you'll see each piece of cereal is that big, right? So that's what's happening is that cereal is just like colliding with that box and shooting off into space. So we got to change some of that stuff. The first thing I'm going to do is I'm going to change my collider scale width on my cereal. So my M particle 1. I'll scale that down until it's actually closer to the actual size of the cereal. The way you can kind of do that is get in here close to one of them and sort of start scaling down. And you'll scale it until it disappears. The reason it disappears is it's going inside of the instance geometry. So it looks like about 0.25, something like that. 0.27. Oh, wait. 0.027. 0.03? Yeah. So about 0.03 is about the size of it for mine. Yours may be a little different. So I'm going to uncheck collision thickness now and look at the self-collision thickness. And if I changed the collide thickness, it should be the same as the self-collision thickness. Which means now, if I go down here and hit play again, my box's collision thickness looks normal, right? So now what should happen is they'll start falling into the box and piling up there. Now, the problem is they're not self-colliding, right? So they're just puddling there and going through each other. And if I hit self-collide, everything will kind of explode a little bit, right?
That's not bad.
It wasn't too bad. A lot of times it's way worse, right? So now I can slowly fill up that box. Now, something you'll notice is I'm getting to frame 200 and the box isn't full yet, so it just goes back to 0.
Because the lifespan, right?
Well, so it's the lifespan is still set to forever.
Oh.
The problem with it is I'm not simulating enough frames to fill up the box, right? So I'm going to extend out my timeline. There's a couple of ways we can make this happen faster. One, well, not faster, but like better, is if I go to like, let's try like 600 for right now, right? If I let it keep simulating out to like 600, eventually it'll get high enough to where it'll be full, right? The other way I can do that is I could change the number of particles that are emitting per second. Now, by doing that, I could potentially cause some explosions to happen. Right now, it's emitting 100, but if I emitted 300, it would fill up twice or 3 times as fast, right? In theory. There we go. So I'm not going to fill it entirely full. I'm going to fill it to probably about, let's try about 200 frames worth. Right? So about there. So I think that's about enough cereal, right? So that means at this rate, if I emit 300 particles per second for about 200 frames, I have about the amount of cereal I want in my cereal box, right? Okay, here's the problem with all of that. We're 200 frames in, our spoon's already in the bowl, right? Remember animating all of that spoon jumping around? Our spoon's already there, right? So like, I really want that. I want that cereal to be in this box when my animation starts. So the way I'm going to do that is I'm going to go to about negative 300 on my timeline. So I can type in negative 300 in this first box. And you'll see now I can go back into the negative numbers before frame 0. And I can use those negative numbers to fill up my box. And that means when it comes time to render, I can still just render frames 1 through 200 or whatever to get my animation. Yes?
So do the negatives show up on the graph editor?
Why is that a bad thing? So really think of this as sort of like buffer space where we can do some stuff before our scene starts, right? The problem with that is if I hit play right now, nothing happens in those negative numbers. Actually, it doesn't start simulating until we get to 0. So you'll see, or until we get to 1, I guess. And so nothing simulating, and then suddenly a bunch of cereal starts pouring in there. So the reason for that is nucleus. That nucleus node that we created that says physics exists, again, just for efficiency, it picks a start time for physics to exist, right? Like if you don't want something to shatter until frame 200, you could leave nucleus off until frame 200, right? So what we're going to do is if we scroll down here to time attributes, you'll see that start frame is set to 1. I'm going to choose negative 300. So now, from negative 300 to 0, actually forever, it will continue to fill up. But I know that I just need 200 frames of serial emission before I have enough cereal, right? Which means I could really stop the emitter around frame 100. So what I could do is go to frame 100 right there. That's where I actually want it to stop emitting cereal. Right? So I'm going to set 2 keyframes on my emitter. I choose my emitter. Right now, my rate is 300 particles a second, right? I want it to emit 300 particles a second from negative 300 to negative 101, right? Right about there. So that means on negative 101, I'll just right-click on rate and say set key. So everything before that will be emitting at 300. And then immediately after, on frame 100, there, let's make this a little shorter so we can see this a little bit better. On negative 100, right there, I'm going to change that 300 to 0 and right-click and say set key. And so you'll see what happens if I just started playing from here. Maybe I can't. Is that once it gets to that number, it's just going to turn that emitter off, right? Because now it's going to be emitting 0 particles per second, right? Let's see if it does it here. And so then at 0, the emitter just stops and everything will fall into the cereal box. A little noisy in there, isn't it? I mean, like the amount of cereal bouncing around. So let's go ahead and hit stop. I'll go back a little bit and hit play. We'll let this fill up and see if that works a little bit better. I think I just had too much cereal in there. actually starting to think that's a little too much cereal. That it's actually just getting, it's like packing in there and like jittering a little too much. It's funny. So it's in the box, but it's still kind of popping and bouncing around a little bit. So I'm going to change the point in which this happens. I'm just going to highlight these frames here. Maybe scoot those back to like 180. We'll just do this with a little less cereal in it. See if that helps. There we go. So they're still kind of bouncing around inside of the cereal box quite a bit. And that's okay, I think. But one of the ways we could sort of play around with making that a little less is under this soft collide here. I think we could maybe turn the bounciness down, or I wonder if I could turn that to like 2. Does that help? And the bounciness is all the way down. What if I just turned friction to 0? Let's see if that works better. So they're still bouncing a little bit. If it still continues to be a major issue, one of the things we can do is under the dynamic properties, I think it is, we can dampen it just a little bit. So I can go like 0.1, and I think that will dampen some of that, some of their like colliding with each other noise that we're getting there. There we go. So now they're still wiggling around a little bit, but it's all right. That's not too big of a deal. I think really what's happening in there is we're just seeing a lot of them trying to sort of settle and find their spot. So here's where we can. Here's where the next part starts, where we're going to break this, right? So we're able to fill out that cereal box. The next thing we want to do is start. Actually, let me go ahead and select that cereal box and turn off this collision thickness just so you can see it. So now I have this cereal box full of cereal. So what we need to do is I'm going to start probably around, if I start watching my spoon jump in, probably around frame 20, I'm going to animate my cereal box picking up and starting to pour cereal into the bowl. Okay? Now, when I do this, because I am not simulating in real time, it's going to mess up. The cereal is going to stay behind. Don't panic about that. So, frame 20, I'll go ahead and hit S because that's where I want it to start. And then maybe over 30 or let's say to about frame 60, I'll animate my cereal box sort of raising up. Now it leaves the cereal behind, but don't worry about that. Moving forward or backward a little bit, rotating to pour the cereal out like this. So I'm just going to take a stab at this and see if this works. Hit S. That means my cereal box animation looks something like that. You like that? I'm a professional. So you could, like, the thing you're going to recognize is that the motion of this box is possibly going to throw the cereal out onto the table. So one of the things we could do is sort of rotate a little bit out a little bit. If that makes sense. Maybe something like this to kind of get a better arc on it. And as much as I can ease into this, the better. All right, so maybe I'll hit S there, and over the next few frames, let that sort of settle. So it's kind of working, right? So I'm gonna play this. A lot of stuff's gonna mess up. Let me see what it looks like. 1. Because keep in mind, all of the box filling up is over here in the negative numbers, and I did this so much that I spilled them all out, right? So I'm going to have that hold a little bit longer, and then I'm going to have it go back to where it started on frame 20. I will say copy that keyframe, maybe put that on like frame 140, paste, paste. Yeah, so now what I get out of this, if I hit play from the beginning at negative 300, let's see what happens. Now, one time in my life did I try this the first time in front of class, and all of the cereal made it into the bowl without pouring out. I think this is a time to address a question you may have. Does all my cereal have to make it into the bowl? And the answer is no. Actually, some of the really good ones we've seen of people doing like crazy stuff with the cereal. At least try it. So here's the thing is, a director is going to ask for something. Let's see if it works.
Yay!
Okay, so you may notice something happened. It all fell through the table, right?
It looked good though.
But it wasn't terrible, right? That wasn't bad. It didn't slosh it everywhere.
You just need to add the collider here.
So let's see what happens. Let's add a collider to these two things. So in cloth, create passive collider. Go back and let's watch it again. So you don't have to get all of the cereal into the bowl on yours, but recognize that that might be a challenge that you would have to do in the future, right? What if you're working on an animated film and the story is that they pour the cereal and all of it goes in the bowl? That is why effects is a job. That's why this is not just the computer did it all. Is because that's hard to make happen sometimes, right? So let's see what happens.
Yay! Oh, it's a cereal.
Cereal, isn't it?
Hold
So what happens if you make this spoon?
So let's make the spoon a collider too. Now the other thing to notice, that cereal's jiggling around a lot. Right. So let's try that really quick. Let's go back and make the spoon a collider. So that seems like a fun little thing here. So we select the spoon mesh. I think I still have it frozen. Go in cloth, create passive collider. So that jiggle that's happening at the end, I think I can change that just by animating the dampening or the dampness and turning that up after the cereal's in the bowl. So that's probably how I'm going to do that. And dampening means it's going to it's reducing the amount of motion that's happening, right? And so I can do that. I think there's also some other stuff I can do to kind of adjust that. But this is getting close. Let's see what happens. I'm going to kind of keep an eye on some of my frames here too. When does it need to settle down by? So cereal comes up. So I lose a couple of pieces in the ground.
Who doesn't lose a couple pieces though when pouring cereal?
Yeah. Okay, yeah, so that interacts with it. So it looks like around frame 130 or 140, I want to animate that dampening happening, right? So maybe let's see about let's start it from maybe 125 right there, 126 to about 140. I'm going to choose my end particles. This attribute editor here, this damp. I'm going to right click on it and say set key. So it's going to be set at 0.1, but maybe by 140, I'm going to turn that all the way up to 10. Click, set key. Let's see if that causes it to slow down. I think this will work. So this is what we're trying for. We're trying to get the simulation to happen in a way that that we like, right? And it's like you've heard the phrase "herding cats." Anybody ever heard that? Like,
Yes.
can you imagine trying to like herd,
Like
keep a bunch of cats all moving in the same direction? But, like that's kind of what this job feels like. You don't have specific control over any of those objects. They're going to simulate, which means all of the things that you have to work with are to try to make that simulation happen better. Right? And so little things are going to happen, like that one little piece of cereal hanging out back there, right? And that's just a painting. Those other few fall out, but that's all right too. So then the cereal kind of settles down, and it kind of completely stopped. But all right. I wonder. I think there's something else we can just conserve do. Okay. I wonder if that collision strength is a little high too. 0.2. So I spilled some of them because I jumped some frames.
That could have went better.
Yeah.
Sometimes you do like that.
Don't you just hate it when your cereal goes to the box?
So it's not too bad. Also, considering I could probably just end my shot on frame 140 or 150 as well, right? So if it ends at 150, all that spilled out was because I did this with it. Right? So let's say I'm going to keep fighting with it a little bit, but let's say this was the final, and this is how I wanted it to simulate. So, yeah, do you have a question?
Yes, and whenever I make the cereal box an acid collider, the emitter just stops moving.
Zoom out. I think that's where it's shooting them up into space. That's where the size of the particles. So yeah, you just gotta change the size of the collision object. Okay. So here's the problem, right? If I change anything, even in the slightest, I will get a different simulation every time. In fact, sometimes you don't even have to change things, and you get a different simulation. I don't really know the math working behind there, but every one of those little pieces that are simulating are calculating differently when you make a change to something. If I move the bowl a little bit, if I change the box, if I change the particle size, any of that stuff would give me a different simulation. And let's say it's exactly where I wanted it, that this is what I wanted my simulation to look like. That means I don't want to break it, right? I don't want to mess that up. So, so what we have to do at this point, did that end up fixing it?
Oh, I had to. How do you change the size?
Oh,
You only got to physically change the size of the cereal box.
no. In the go to your attribute editor. So it's that you have this serial selector, you know, particle ones. And then so it'll drop down this is off. So that's the size that it thinks it is. But it's changed as the collision with scale at the top of there versus one. Okay, so put that down there. Okay. And I think I have mine set like 0.03, so it's probably somewhere near that. Okay, so I want this simulation to stay like this, right? This is where there are two videos up on D2L. There are two ways of making that happen. One is that we can cache this. So not C-A-S-H, C-A-C-H-E, right? Anybody heard that word before? Where do you usually hear it? What context? Yeah, the internet. It's like saving a cache file or something, right? And so that's what this means here too. is basically Maya's going to create a file outside of Maya and save it in your project. Let's see what this simulation looks like here. So I left a few behind. I think that's where I turned my collision strength down. Okay, sorry. I am very nitpicky about this. Let's do one, and then okay. I'm not gonna sweat this too much right now. Mainly just for the sake of the lecture. I would play around with a lot of these. A couple of things I would consider doing is maybe turning down some of the mass or some of that stuff just to see if I get something a little bit better. So let's see what happens here. Pours out. I lost one that time. A few more. Other things you could do is maybe emit a little less time, because maybe then there'll be fewer of them in there and they wouldn't be quite as noisy. So we have this. The other thing I guess I could do is I could just have that drag turned up just a little bit throughout the whole thing, right? So there's a couple of different things I could play around with. But let's say this is it. Let's say this is, we've fought with all that stuff, we've gotten it to where we want it to be, and I don't want to change it anymore. I want it to stay like that, right? So that's why we're going to cache it. When we cache it, what it's going to do is save a file that tells Maya this is where each of those particles are supposed to be for each frame, okay? So once we've cached it, I can't change the simulation anymore until I delete that cache. So the way we do that, I grab mParticle1, and I go to in cache, create new cache, and I'm going to create it for an in object. Now if I choose my options here, you'll see it's going to save it in my project folder, right, where I've set my project. This is important. If you haven't set your project and you cache this out, and then you go open it on a new computer, Maya's not going to be able to find those cache files, and your simulation's not going to work. Okay? You'll have to delete the cache, re-simulate it, recache it, and all of those things. So this is what I'm going to call it: evaluate every one frame, save every one evaluation. So basically, the default settings is fine, but I'm going to hit create, and it's going to simulate this one more time. But then it's not going to change anymore. After that, I can scrub my timeline, and the animation won't change. I'll kind of show you that. Now, again, the purposes of this is so we can, so we know when we render, we know exactly what's going to happen. So we're going to talk about one more thing here in just a second, too, about the render farm. If you submit this to the render farm without caching it, basically what you get looks like static. Like all of the motion of it is just everywhere. And that's because one frame 20, may be rendering on this computer, the frame 21 is rendering on that computer, and they can't tell each other what the previous frame looks like without that cache file, right? So you would get this crazy, noisy, like static. It just looks like everything's jittering everywhere all the time. So let's see here. So it's saving a whole lot of files, and then we get that, or the serial moves, and then that's the end of my animation up there. Okay, so here's the cool thing. After I've cached it, now I can scrub in my timeline and see this happen in reverse or in real time. And that means if I wanted to go now to this view and play blast this so I can see what this animation looks like. Let's escape. Let's play blast it in a better size. So choose my format. I always do QuickTime, H264, scale. From Windows is fine. Save that file. Play blast. So it's play blasting from -300, but since I've cached this, I can now reset my timeline to be from 1 to 150, and we can start seeing what that looks like. Actually, yeah, let's go ahead and do that just so I can. Make that happen. Okay. So now this should be what our final shot will look like after we get lighting and rendering in it too. Rig ready to enemy. Let's see if I can find that. I don't know why it didn't automatically launch it, but fast. So, yeah, that's feeling just a touch fast to me. So I probably would do a couple of alterations on mine. So let's say I watch that and I'm like, you know what, that's not looking right, which is what I did just say. What I'm going to do is pick that in particle 1 again, and then I can go back to in cache, and I can delete the cache. And so now I'm back to where I was, where I'm having to simulate this again. Now, a couple of things I can do. For me, that was playing just a little too fast, like especially the simulation part. So one of the things we could do is we can play with gravity a little bit if we want to. Right now, gravity is set to be simulating at 9.8, which is actually the right units. Like that is a physically accurate unit. But I could turn down gravity just a little bit. Let's try if I did something like 5. Then you'll see like maybe it's not going to have so much gravity pulling on it. So hopefully it won't simulate as fast and as jittery. It also means though less of my cereal will probably pour out of the box. So let's see what happens here.
Oh.
That's where I have that dampening turned on it. Let's get rid of that. Those keyframes right there. I don't know if I need that if I've turned down gravity. Actually, I'm going to turn down gravity just a touch more. That still felt a little fast. Let's do like 4.
So are you in real time right now?
I think it's going to play back every frame the max real time. So that means it slows down once Maya starts bogging down. But it won't play it faster than real time. Actually, I think that's feeling better in terms of speed now too. And kind of see that they're. There we go. So kind of liking how that's looking a little bit better now. So again, now I can do the and particle, and cache, create new cache. So I'm going to go ahead and save this really quick because there's another way we can do this. Right? The other way we can do this is to turn all of those particles into actual pieces of mesh, right? Actual additional spheres that are in our scene that all have keyframes on them. Now that's a little bit slower and a little bit heavier, but what it would allow me to do is anything that falls out of my bowl, it would allow me to delete that. So the way we can do that, actually I have to remember how to do this, is under Mash, and then under Utilities, I think it is, there is a bake instancer to objects. So Mash is a different software package that's in here. It's actually built for motion graphics, and this is a really interesting option when we try this, because what it also allows us to, it will basically set keyframes on everything from frame -300 to -150 on every one of those particles and convert them into a sphere. So I've actually had this crash on me before. It also goes really slow. So I'm going to hit this button, and then there's a chance Maya's going to freeze up on me eventually. Let's try it. Bake instancer to object. Oh wait, I have to choose the instancer, not the end particle. So I choose this instancer 1.
Well, where's the instancer? Or you made that earlier?
That's when I created the instance of the sphere. It created that little node. So I selected the serial and then I did create instancer. So utilities, bake instancer to objects. Let's see what happens. So I get this little update over here. No problems with the parent. Object position 00. Okay. So I'll say bake animation. And then we get a fatal error. So,
And it's gone.
I'll reopen it. It's fine. So I'm not saying, again, this is an alternative way of doing it, but what that will allow you to do is then it'll allow you to edit some of those animations, right? If you specifically wanted one of those pieces of cereal to land in a specific spot, then I could change the animation on that to get it, right? So there's a reason to save it beforehand. Open scene. That one. Open. Okay, let's try it one more time and see if it works. This mouse is sticky. It's like not moving right. Why is my mouse not showing up? Is there a there we go. Sorry. My mouse wasn't moving right. There we go. Instancer 1. Mash. Utilities. Bake instancer to object. I only need the translate channels because there is no rotate on this. So let's just do that. Bake animation. Ah, really? All right. So that's not wanting to work very well. All right. So I bet it's partially because I'm pulling it from the network. So if I had this locally on my computer, hopefully it would work. Okay. So that's not going to work here in the demo. If you want to see how it works, there is a video online or on the D2L page. I believe it's because right now I'm working off of the network instead of locally on my computer, I believe. And so that's part of why that's not working. Okay. So I want to do one more short demo, and then I'm going to talk about the render farm. And then we could be done today. So what time is it? So 1:14. So the other thing is, if you decide you want to simulate cereal that is a different shape, right? So let's go ahead and try just an example of that. Let's say you're doing Cheerios instead, right? Or Fruit Loops or whatever you want to do. Give this a color, we can see it. Or Apple Jacks. So I'm going to, under effects again, I'm just going to kind of build this really quickly. We'll go to M particles, create emitter. Go ahead and move that emitter up to here, just so we can emit onto this plane and see them move. If I hit play, start spitting them out, right? Select this, NCOF passive collider. Right, so they're going to hit that, start rolling down it, right? And then I can select that torus that I made and the M particle. I can go to M particles, instancer. And so now you see what I get is this, right? But you see how every one of them is flat, right? They're not rolling. And that's actually the problem with this. Even if I go in here and set this to self-collide, right, they're still going to stay flat. Right? And that's because these particles, Maya is thinking of them as a dot, not as an object. Right? And so it's only calculating the location of that dot because it doesn't matter which direction a dot is pointing. So to make this work with rotation, we have to add a couple of extra things. So the first one is we have to go here to rotation and say compute rotation. Now it'd be nice if that actually worked. But it doesn't, it just gives us that, right? So that means we have to go down a little bit lower here. Sorry, I'm going to have to find this really quick. It is, yeah. So under instancer geometry replacement, we see this rotation type here, and we have to click that and say, is it particle ID? No. There it is. Okay, so we got rotation per particle. Is that right? Rotation PP. And then rotation type particle ID. Does that do it? So it's kind of working. We're kind of getting some rotation on there. Right? It's just not giving us exactly what we want. So I think that there was another thing we had to add here. Note. Oh, just give me a second. Let me look at what I had it set on the video really quick. If I turn rotation, insert geometry replacement, you'll see that instancer is calculating the position, but it's not calculating the rotation. Cool. Then we start getting some rotation on each particle. However, it just... Now, these donut shape.
our solver display again, this is the thing that is simulating. So a little small,
I think
we're
that's
going to
it.
kind of go through each other a little bit. And so our objects are rolling once they get here.
Yeah.
And so that's
it.
not exactly how
Um,
Serial would simulate.
so I think there's some other stuff kind of happening here. So I don't have to worry about the particle ID. It's just this rotation per particle. Okay, I see what's looking weird about it now. So this is actually working. It just looks crazy. And the reason it looks crazy is because they're still kind of colliding, right? So even though we went up here to self-collide, they're still kind of going through each other. And that's the reason. The reason for that is because each of these particles, if you look at their collision thickness, what's colliding is that little bitty yellow ball. Right? So the collision thickness for this needs to be bigger. It needs to be about the size of this Cheerio thing. So maybe about 3. Let's try 3. 3 seems like about a nice middle ground there, right? And so when I hit play now, at first they're going to hit and they're going to act a little bit weird when they first emit there, but when they hit the ground, now they're actually going to rotate. Okay? And we should be able to see that as rotation now as they're pouring out of the serial. Now, the problem with this is they are still going to simulate as if they look like this, right? So that means they're not going to touch each other very closely. Those Cheerios are going to roll as if they're a sphere, not as if they're a Cheerio. And so you still have to you have to balance that to where you get the best effect that you want. So maybe something like this looks better. And you just kind of have to simulate that until you get what you're looking for out of it. That means if they're all going into a bowl, you should consider like how they look after they're all in the bowl. Are they too separated? Like, are they sort of spread out too much? If so, maybe make that collision thickness a little smaller so they are closer, even if that means they're kind of blowing through each other a little bit. So. Okay. That was a lot. The bake instancer thing is kind of the annoying part to me that's not working. I think that it'll actually work here, though. Let me try this really quick. If I tried to bake the instancer on this, again, I think the reason it's not working is because I'm pulling it from the network. And since I haven't saved this one to the network, if I go to this instancer, mash, and did bake instancer to objects, I need to do translates and rotates, bake animation. Really? All right. So try it on yours. See if it works on yours. Does it crash yours too?
Well, it did crash before, and I was like, okay, fine. So I went back in, and now it's giving me the warning stuff, and it won't let me do it. I think it just has PTSD.
Yeah, there's a lot of issues with Maya right now, particularly running on these computers. So I don't necessarily know what the issue with that is. So.
I'm gonna try it again because it won't let me simulate at all.
At all?
Yeah.
Okay, I'll help you with that here in just a minute. So there's one more thing I want to go over before we spiral out of control here. So one last thing, ETSU E3, right? DIGM students, student resources, right here, render farm instructions. Okay. Has anybody ever used the render farm before?
Who's ready to break some computers?
No, but I just and it looks really complicated.
So, how did it work for you?
I'd say 1 out of every 5 times it's worked.
So I will not. This is the video to watch. This is Marty, who kind of designed the way the render farm works. This is him walking you through what you have to do. It's a little bit of an older video, 2017, but it still should be applicable. What you're going to be using, and I'll just give you kind of the rough, fast version of this, is something called Qube, Qube, right? So look at all of those red ones that say failed. You see that?
Oh.
Versus all those blue ones that say complete, right?
And there's also the ones that are still running.
And then there's the green ones that are still running, and then these that were, yeah, they're slowly dying. Does Dusty Graybill even still go here? I guess he does. He's probably just in a different class. Yeah. So you'll see a lot of these that are trying to render these Houdini mantra jobs. That's the effects animation class. Right? Some of these others will say Maya job or these. Those are more than likely, if it doesn't say Houdini, that means it's a render farm for a Maya project. So for this to work, I'll kind of explain it to you. That student resource or that student folder we were looking at, DIGM students. Under here, there is a folder called Share, SHARE, and you can create your own folder under here, where you can put your files. For the render farm to work, your entire project has to be there. Also, you had to have set your project all along and everything needs to be working correctly. So that's a lot of what he talks about in that. But once it's up there, you would submit a project. You could, let's take this one here that's complete. Oh no, let's not do that one. Let's do this Maya job that's complete. I can right click and say resubmit. And it's going to bring up this, right? And this is where I would put in all of my information for my project, right? Where are the files for it? Where is it going to render it to? That's what that video will walk you through easier or better, right? So once you have all of that and you hit resubmit, what it's going to do is it's going to submit it to all of the different worker machines. Anybody been in 195 downstairs, the lab downstairs?
The two.
Yeah, you know that big wall of computers that is back there in the back of the room? Those are the ones that are named restaurant names. So there's Cookout, there's Wendy's, I think there's a Powell's and
So it's all big names.
KFC for some reason.
Yeah.
So all of these others though, DMC 29028, look at that. That's interesting because that's one of these computers. That means it's trying to, actually what this may be is people logged into those. No, it's trying to render on some of these computers up here. So if your computer is running slow, right click on it, go to Task Manager, and see if under More Details, under Details, sort this by memory, and see if you have one in here called Maya Batch or one called Mantra. If either of those are using up a bunch of resources, that means that what's happening is the render farm is using that computer you're setting at to render. Right? And that's why it's going kind of slow. It says some of that's happening here, but maybe this may be an older list of it.
So you can just kill it off.
Yeah. And I think to kill off Mantra, you have to kill the worker node. Mm-hmm. It will mess up that frame of it. So basically what happens is this is all of the computers in the building, right? If it's gray, it means it's down. If it's yellow, it means it's locked. So that makes sense. This means somebody is setting at that computer right now, right? That makes sense. We are 290. So it's saying that one's locked, right? So basically these are all of the computers in the building. But if nobody is setting at that computer using it, the render farm will sort of go into it and start using the computer to render one frame. Okay? And so then you can start seeing your project render one frame at a time. So right now, Professor Osteen is rendering some stuff too. And so it's using computer 285 over there in that room to render one of her frames. It's rendering one frame of one, right?
Well, it's in our room too.
Yeah, no, that's why I was wondering if that was actually showing up. Like, if anybody's computer's running slow, it may be, the render farm's not supposed to do that, but sometimes it can. And if that's happening a lot and it's locking up the computers, then we can do that.
Why just one?
Huh?
Why just one?
Well, so here's the way to think of it. If we have 100 computers and 100 frames to render, what's going to happen is it's going to let each of those computers render one frame, and you could render your entire animation in the amount of time it takes you to render one frame. Right? So really the right way of doing it is being a little bit more friendly about it, because everybody needs to use their render farm. And if you say I'm going to use 25 computers to render my 200 frames, right? Then that means each computer has to render 8 frames each, and you can get your render done in 45 minutes, right?
So you can like
If it doesn't crash.
kind of mess with it to see
If it
how.
doesn't.
I don't know.
Now, as Kate said, it works like one out of every 5 times. The render farm, because it's just kind of a delicate system. Like it really is. Like it's it's like a house of cards. It's very easy to knock this thing over.
Will it screw it up for other
I saw
people?
stuff like that.
Yeah, it
I
will.
mean, like, will mine screw it up or something?
No, when you submit yours, you're not going to break somebody else's. But what I would say is it takes a little bit of time to get it to work the first time. So if you're wanting to use this project to do it, I wouldn't start the night before it's due, right? I would,
So 2 nights.
yeah, take a couple nights, because it may not work and you may still end up having to render it on one computer, right?
Well, is it legal to just log in to a bunch of computers?
Legal.
Legal. This
That's
project
probably
better than last time. That's what I did last time, but I only did that.
There is there's sort of an unspoken but sometimes very loudly spoken sort of courtesy of it's not that big of a deal during the middle of the semester. If you come in here, the room's empty, log on to a few computers and render that out. What is sort of uncouth is when you're logged on to 8 computers in the middle of finals week and people come in and like, I need a computer to do my project. At that point, it's completely fair game to just unplug the computer and kill your render and then start it back
So
over.
what, can we do it in the middle of the night?
So yeah, if there's nobody here, if you're hanging out in here and there's a couple of extra computers, if you want to render on a few of them, that's fine. What I wouldn't just kick off 10 of them to render and then go home and go to bed. And if you can tell that the labs are getting busy, make sure you're not hogging a computer that somebody else may
Can
need.
you leave if you have all that farm going?
Yeah, so
I do that
if
on the daily anyways.
you can kick off a render on the render farm and go home and go to sleep, right? Like you log off the
I don't know
computer.
if I trust.
Yeah, usually what you do, so what happens is when it starts rendering it, you will start seeing the finished renders go into your folder.
And then you go to sleep.
Right. You'll start seeing them go into the folder, and after you have a few of them going in there, you're like, okay, it seems to be working. I can turn off the computer and go home and go to sleep. But the render farm it's rendering it off of your computer anyway. Your computer actually isn't rendering anything. You can submit something to the render farm and keep working on another project. And that's probably how I would
Wait, so your
recommend it.
computer wouldn't run slow? Like, while.
No, it's not rendering on your computer at all. It's rendering on all of the free computers.
Yeah.
Right? So, yes.
So it's a little off topic. Could you connect a separate computer to the network?
Maybe. Like a laptop, bring it in and get on there. I think so.
Do you have to bring it in to be connected? Because I know the.
Oh, can you kick off a render from the render farm from home?
Wait. Okay, so does the render farm only work on the computers in this lab? Because you can access the E3 server from the computers in Gilbreth.
If it has Cube installed, you may be able to do it from there. But you probably can't do it from your dorm or something like that. There are also we're kind of looking into the option of not having an actual physical render farm here. Possibly doing cloud rendering, so using Google servers or something or Amazon web services to create a render farm that way. But that's in the future. So just recognize render farms are something that eventually at your time here, if you're doing anything in animation or effects, the render farm can be your friend. You're going to love it if you can get it to work. So I would say fight through that when you have a little bit of time to do that, because it's getting the first one to work is the hardest one. It's learning what not to do wrong. Eventually, things mess up on it. The render farm will crash, so don't rely on it too heavily. It's happened more than once that the render farm messed up the night before a final was due, right? And people were freaking out. So plan accordingly and test out the render farm. But once you get it working, it's really nice. You can render out like your entire thing in less than an hour, and then you get to see it, and it gives you more time to iterate on it, right? Rather than waiting 8 hours for it. When you render it like that, you see something's wrong, you're like, crap, I'm not going to render for another 8 hours. But if it only took 45 minutes to render, maybe you would, right? All right. So, any questions on any? I'm sure you have lots of questions on all this. I feel like I lost a lot of you today, and that's okay. That's why I recorded it. That's why there's actually another version of it recorded up on D2L. So I'm going to go ahead and shut up because I think I'm losing my voice. I don't know if y'all can hear it. It's getting a little scratchy. Yeah, this semester, like 4 more weeks. 4 more weeks. We can do this, y'all.
Drink some tea.
Drink some, yeah.
Tea with honey.
Yeah, we're week 11 of 15. So,
Yeah, after Thanksgiving break, we have 2 weeks before Christmas break.
right.
That's actually kind of scary. I don't like it.
So now we got we're on track. So again, reminder: the final or the project is not due next class period. It's due a week from today. But you should be here next class period because we're going to start the final next class period. Which means I'm not going to do anything. Like I'm not going to have a lecture that I cover about the final. I'm just going to explain to you what the final is so you can get started on it in your spare time. So. Otherwise, class is yours. Thanks for yes. What? Okay, give me a second. Let me stop the thing and upload it. That way, you have the video and then.
Oh yeah, that's right.
Oh, what's happening?
It's a play out there.
What?